Hi, my name is Guang, 12 years old. For this lesson, we'll be continuing on with techniques and applications of definite integration. For this lesson, we'll be having more examples. So over here, first we have double integration, and the boundary is basically d over here, and then e to the power of y squared times x minus y. Hi, d sigma minus 1 over 4. Integral from 0 to 1 e to the power of x squared dx, and what is d? D is the area bounded by x is bigger or equals to y and smaller or equals to 1, and y is bigger or equal to 0 and smaller or equals to 1. Okay, so for this part, I'm going to draw the graph and draw and show the area bounded over here. So first we have here we have the y-axis and the x-axis. So you can clearly tell here that 0 to, y is basically from 0 to 1, so let's just call this part 1, okay? So over here 0 to 1, and what we're going to have is that, so you can clearly tell it's from 0. Let me just okay, so over here now that I have gotten this part, so what about x? So x is bigger or equals to y. Hi, so over here what we're going to have is that okay, so what is this line? So this line is y is equals to x, okay? So now that we have gotten here, what we're going to have for this part is that, so x is also smaller or equals to 1, so what we have here is also 1, okay? But wait, where is the area bounded? So the area bounded for this part is going to be, because that for y it is from 0 to 1, so it just keep on stacking. So for this part what we're going to have is, so this is the area bounded, okay? Alright, so we have gotten this. Now we can find the boundaries for x and y, right? So let me just quickly write this down. Okay, so for y you can clearly, so we're going to go for with respect to x first, then y. So over here for this part, y it is obviously from 0 to 1. Then what about x? So x is bigger or equals to y and smaller or equals to 1, right? So over here for this part, what we're going to have is that the boundary for x is from y to 1, okay? So now that we have gotten this part, what we're going to have next is that, so over here you can change this to dx dy now. So dx first and dy. And if you're wondering for the part behind why I am not actually trying to integrate it and all, well, it's because I cannot. So for this part, you may be wondering then what's going to happen to this in the end? Well, you will see later on. So first of all, for this part, what we're going to have is just straight up integrate for x already. So what we're going to have is e to the power of y squared bracket half x squared and then minus xy going from y to 1, and then here we have dy. Okay, so behind part this is going to stay the same as we cannot solve it. Now that we have gotten this part over here, what we're going to have is that we just sub it in, substitute it, so it will be so first is half, basically 1 squared times half, and then minus y squared over 2, and then minus y, which is 1 times y, then plus, because 2 negatives, and you have y squared dy. Well, for this, it will stay the same for once again. So what we're going to have 1 quarter 0 to 1 e to the power of x squared dx. Okay, so now that we have gotten this part, what we're going to get is that, so in case you didn't realize it, so first of all you can separate this to different parts, like half integral from 0 to 1 e to the power of y squared dy, and then for this part you minus of, so your minus of integral from 0 to 1 y e to the power of y squared, and then dy. Then after that, these two you can minus and you'll get y squared over 2, which will add on with 0 to 1 y squared over 2 e to the power of y squared dy. And in case you didn't realize, for this part, the boundaries are the same, so once you integrate both of them, and since they're independent of each other and the boundaries are the same, so technically speaking, this part is basically just 2 times of this part, which will be, so for this part what you're going to have here is that, so you can also change it to y, because that for this, actually for this part, you can have any unit here, so this is, if you're only talking about values, then the value of this is basically just twice the value of this. Okay, so that means that you can technically do this. Okay, alright, so now that we have gotten this part over here, what we're going to have is 1 over 4 integral from 0 to 1 after those two minus, then e to the power of y squared dy, and then minus, for this you can place it in here, and when you place it in here, there'll be a half integral from 0 to 1 e to the power of y squared dy squared. Well, technically speaking, over here, you can solve it now, because solve this part now, because although you cannot solve for when it's y squared, but technically over here it will become it will be like e to the power of x dx, which you can clearly integrate. And now that we have gotten this part, what we're going to have next is like this. Okay, so now that we have gotten this part, what we're going to have next is, so for this, the first part will still stay the same, then minus. This you can integrate already, which you'll get 1 over 2 e to the power of y squared, integral from, bound from 0 to 1. Well, for this part, you'll add on with 1 over 4. So this part you can put this inside and you'll get from 0 to 1 y d e to the power of y squared. And then the first part doesn't change again. So over here you're minus. So for this part, if you sub in 1, it will be e to the power of 1 square, which will be e. And then over here you have 0, which will become half. So here you're plus. So sub it in, it becomes half. Then for this part, you can use integral by parts and you'll get from 0 to 1, and then you're minus 1 over 4, integral from 0 to 1. And what you're going to have here is this thing inside instead, e to the power of y squared dy, and these two will be able to cancel out, so these two will end up being nothing. And you have half e plus 1 over 2. Well, for this, if you sub 1 in, it will become 1/4 e, and if you sub this part in, this will just become 0. And thus over here, if you put these two parts together, what you're going to have is half minus 1/4 e. And this will be what we get for this lesson. So for this example, this is the solution that we get. So first we have to find the area bounded, which in this case over here we have the y is equals to x, this line, and then both y and x at most it can only reach until equals to 1, while for x it will be going from y to 1, while over here for y is from 0 to 1. So mainly what we use here is just as integral by parts, and that's all. Well, as you can see, as I said from the start, that this part may not be solvable, but in the end we get to cancel it out. Well, that will be all for this lesson. Last but not least, thank you for your watching.